Okay, so good evening, and I think if you do more amount of lives in a single day, it takes more time. All right, so let's start this Python. Okay, we are going to save everything in a project directory. Okay, so we already have a Python file. So we are going to speed run through these things. Should we do that? So, since these are small, we are going to start with the idea, the comment lines itself. So, largest among three numbers. Take three numbers, find the largest, return it. Doesn't matter how you do it. So, num1 is equals to integer input. I'm speed running it, so just focusing on the logic. Right. So, and you will take num2 and you will take num3. If num1 is greater than num2 and num1 is greater than num3, print num1 is greatest. Show me. And if num2 is greater than num1 and num2 is greater than num3, print num2 is greatest. Assuming we are doing unique numbers, print num3 is greatest. That should work out. Let's do 10, let's do 2, and let's do 30. Alright. Plus for integer string. Okay, you cannot concatenate this. You need to put a comma. Let's do 40. Alright, 40 is greater. So since this block got executed, it only gave error here. If I give like num1 is greatest, let's do 100, 30, and 40. 100 is greatest. Okay, that's working fine. And we got it. Right. I guess I need to pop out the chart as well. Right. And what is the second one? Prime numbers within a range of numbers. So what's the logic? You are going to iterate through the range, take lower and upper, and mod operator from 2 to that number. If there is exactly divisible, break and print it. So why am I doing this? Let's do lower is equals to integer input. Enter the lower range. Upper is equals to integer input. Enter the upper range. Right. So for I in range lower comma upper plus 1, because it is unexclusive. If for num in range 2 comma, alright, it should be an exclusive. So you are starting from 2 to the number before I, and if the num mod IA Where is this mod? Num mod I is equals to 0. Okay, break it. And it did not pass this. It did not pass through this loop. So then you will else print the num. Alright. Let's do 10. Let's do 1 to 10. Num is not defined. What do you mean by that? Mm-hmm. Okay, this logic seemed intuitive, but let's not mess with this one. What is wrong? Okay, this is sounds wrong. This is wrong. Iterating number 2 to a minus 1. Okay. Max 2 comma lower. Why do I always get this prime number logic wrong? What does this max function do? Okay. What? Competitive program. No, thank you. Okay, you are iterating. Got it. The num is declared here, so its scope ends here. I mean, the num is declared here, so its scope ends outside of the for loop. That's the problem. If I is greater than 1, let's do this. Nope. For num and range lower, comma upper plus 1, you are iterating through the number. And if number is greater than 1, because what? No, what? Alright. If number is greater than 1, then you are going to iterate through that I from 2 to num. So I is the smaller one, and you need to num mod I. If num mod I is equals to 0, we will break it here. You will break out of the for loop. If it did not, okay, this is not needed. Print that num. This works. What the heck? Okay. Again, the problem with indentation. See, the thing is, if num is greater than 1, you need to print it. This works now. Yeah. And if you do that, it works now. Okay, it works. So that's not how you check it. So 10 and 100. Nice. Nice. Okay, this creates a new file. I got it. Save, yeah. Prime. This should work. Temporary variable. Num1. Let's do it. Static. Right, so it becomes num1 as num1 plus num2. And num2 becomes radius 20. 30 is being stored here. If you do 30 minus 20, 10 will be stored in num2. So it should print 20 and 10 right now. Yes, sir. So control this works here. Swap. Okay. With suitable examples, arithmetic operators. A is equals to 10, B is equals to 20. Okay, so you can print A plus B, you can do A minus B, you can do A times B, you can do A by B. Dude, what? This is the floor division. What's wrong with this B? And you can do the mod, and you can do the exponentiation. All of this works. So 10 power 20 gives a very wrong number, as I thought. So arithmetic. Okay, and we got relational operators. What? Relational operators, so they give relations. A is equals to 10, B is equals to 20. Print A greater than B. Print A less than B returns either true or false. Print A greater than equal to B. Print A less than equals to B. Print A equals B. Print A not equals B. Nice. Relational. So assignment operators, okay, you are assigning the value. That is normal assignment A plus or equals to. Let's do it like print A, let's do A plus or equals to 1. Let's do that. Alright, A minus or equals to 20. You get the idea. What minus or equals to? Print. So this should print 10, this should print 11, this should print minus 9. If I'm not wrong. Yes, sir. So assignment. logical operators. Alright, so logic. So you deal with the boolean print A and B, print A or B, print not A. That's it, right? And or not. Okay. Logical. Ternary operator. So do if the case, else do that. Print this. A is equals to 10, B is equals to 20. C is equals to print A is greater. We're going to print A is greater if A is greater than B, else print B is greater. Can you do this? Nice. Or you can also do to make it store the string, right? You can remove the print statement inside the C. You can also do this. You have the same result. That's nice. Let's put it in hash. I mean comment. Print A is greater if A greater than B, else B is greater. Uncommenting this is going to give a result. Nice, dude. So ternary, not pi, and nice. So bitwise operators is you do bitwise manipulations. Yep, I got no comments. You got bitwise and bitwise or bitwise not bitwise XOR. Left shift, right shift. Okay, bitwise and bitwise or bitwise not bitwise XOR, left shift and right shift. Let's do A is equals to 10, B is equals to 20 because why not? Print A bitwise and B. Print A bitwise or B. Print not A. Print XOR XOR. That is XOR. Yes, sir. Print XOR B. Print A left shift to A right shift. Let's do B right shift 3. So you have this 2, right? You have this. Okay, guess you don't have this. Yes, you know. Alright. So how are you going to save it? Bitwise operators. Membership operators. In is the membership operators. Let's do a list. 10, 29, okay, 15 and 40. That's a list. So print 10 in A. Both are going to return true, by the way, not in A. True and true. Membership. Yes, sir. Identity operators. So is identity or operator. A is equals to 10. Let's do b is equals to 10. And a is b. That will return 2. And c is equal to, let's do a list like 10, 20, and do d as a list like does the order of values matter in a list? Let's check it out. C is d. True and false. Okay, list order matters. What the heck? Uh-huh. No, can't you do it with lists? Is okay. Access check identity, not equality. Point to exact same object in memory. Python caches small integers. Python caches. Okay, so let's do it 10 times 5. So then it will return false as well. Okay. Then nice. Just to make sure it is supported by Python. Cache small integers. Okay, I'm living my life not knowing all of this. Mutable objects. Same values. Two separate objects in memory. Got it. Is the identity operator. Is the identity operator. If both values are stored in same memory. Python caches for smaller integers, so you will get true. But lists are objects that are automatically created. They are separate. So list 1 equals to list 2 returns true if the contents are equal, but list 1 is list 2 returns false even if the contents are equal. So what if you swap them? Then also you will get that. Order matters. The order matters. As you can see, order matters in list. That's good. Identity. Okay, I have learned a new thing. Just by experimentation. Multiplication table, you are going to use a for loop for the number of elements you wanted to print. That's it, no one's over here. That's great. Okay, this is going pretty good. The battery is really down. Okay, doesn't matter. So num1 is equals to integer input number for I in range. Let's print from 1 to 11 if you want to print from 10, or if you want to print from 1 to 20 it will be num from 20. Print 2 times 1 is 2, right? So 2 is stored in num1 comma times so x 2 times, so I, this is I, right? Then you need to print is equals to let's print num1 times I. This should work out. Let's do a 17 table. Yes sir, it is working. Okay, so we are going to save this thing as multiplication table. So multiplication of complex numbers, take the complex number, or you can just give it like 5 plus 10. You can do it as 6 minus 4j. Print a plus b. Print a times b. You can do the arithmetic. Can you divide two complex numbers? I don't know. And c is equals to, just like you take the integer input, you can do complex input. First complex number d is equals to complex input second complex number, print c plus d. You can do that, print c times d. Okay, you can divide. Let's do 10 minus 2j and 5 plus 3j. Nice, it worked. What? Complex. So function for that def func, let's do that. Multiple return values. Okay, let's return 10 comma 20. So print, you can print the func directly, or a comma b is equals to func. You can do that, print a comma b. It returns the list and it returns the separate values. See, I mean a set. Function with multiple return values. It is a big name. Oh shit. Alright, it is a big name, but it does the job. Default arguments, you can give a function default arguments. Def add, let's do a is equals to 10, b is equals to 20, the classic numbers of Python. Return a plus b. So add, let's do 30 comma 40, and you can store the result res1. You can do that. You can directly print it if you want to. You can print res1 or res2 is equals to, let's do the first number as 100. So we take the second number as 20 by itself. So it will give result as 120. Res3 is equals to add the default, and it will give you 30. So 70, 120, and 30. That should be the case. Nice. Default func. Right. Nice. Length of the string without library functions. You are going to iterate through the string and increment the counter and print the counter. It's really as simple as that. Will the battery stand out? Yes, it will stand out. Anybody is there in the stream? Nobody is there in the stream. Alright. What do we got? Right. Alright, so let's continue. So string, let's do the string one. Let's do it Shankar. The length of the string is 6. If you print out length is equals to len of str1, it will print it. I mean it will print 6. But we are not supposed to use the default functions. This is the function way. Let's see the manual way. Right, so counter is equals to 0 for I in for okay, range is for integers and string 1, counter plus or is equals to 1, print counter, both will print 6 if I'm not wrong. Alright, length of string without predefined functions. Okay, it worked. Substring is present in a given string or not. So for strings you can use the membership operator. Membership operator, right? Yes, sir. Built-in operator. So let's do the string 1 as Python programming, right? And let's do the string 2 as Python, and let's do the string 3 as programming. So we will print string 1 and string 2. No, actually string 2 in string 1, because this part is present in this part, and string 3 in string 1 works. What's wrong? Okay, true and true. Substring. Wow, we have, how many have you done? I don't know, list operations. We are at list operations. So we done 10 programs without any problem. In less than, let's say, 30 minutes or what? Yep, 34 minutes. We might complete another 6 to 7 programs, so or even more, or even we can complete another 10. So list operations, create a list. Operations on a list. What are the operations on a list? Addition, insertion, and slicing. Those are operations, right? Built-in functions are different. They return the values. Addition, okay, let's do a list 1 is equals to 10, 20, 30, a basic list, and list 1 dot append, adding at the end. Is that what he wants? Yes, built-in. Okay, operations. You are appending the 100 and list 1. You are inserting, let's say, the index here. This is an integer, okay. And the index 1, you are inserting, let's say, 15, right? And you are storing sliced list. Let's do sublist is equals to list 1. Do we have a slice method? No, we don't have a slice method. So let's do from 1 to 3 and print sublist, print the list, print the list 1, obviously, list 1, print list 1. This should work. Indices must be integers, not tuples. So is this the syntax? What is the slicing? Okay, colon for slicing. Okay. So 1 to 3 is from like 1 to 3. Okay. So this is and exclusive and you use colon for slicing. List operations. This should work out. And it returns the slice list. It won't make modifications in the original list. I think I should have included that. Built-in function. So we got length of the list. We got built-in. Okay, it is a function. So it will be of the function format. The name of the function followed by parenthesis. Length, min, max, add, and what? Okay, you have length of the list, you have min, and you have max, and you have add or sum. Okay, it's not add, it's sum. It will return the sum of the list, and it will return the list in a sorted manner. Right. So, like usual, let's get our list 10, 20, 4, 5, 6, 9. Alright, print len of list 1. My bad. Print min of list 1. Print max of list 1. Print sum list 1. Print sorted. Sorted is a function, okay. List 1. Do we have a help here? Shortcut summary. Okay. Skip. Spider documentation. IPython documentation. Console help. Okay, guess we are going to. Do we need internet for this? Okay, no, thank you. So this should work out. All right. The length is 6. Smallest is 4. Biggest is 40. Sum is 54. So these are what? Built-in list functions. We came to unit 3 already. Wow. And we got almost 20 more minutes. Yeah, we got 20 minutes exactly. Okay, 24%. I guess I need to turn this thing on. Right. Good. So create a tuple with parenthesis with a pair of parentheses. Concatenation is adding two tuples together. Right. Is equals to, let's do 10, 20, 30. It is immutable. What is muting? Let's get this. What is immutable? Unchanging over time. Okay, muting is basically changing. Immutable is unable to change. Exactly. Let's do 40, 50, and 60. Okay, there is an age-old question: what is attribute in Python? Class, instance, and attribute. Classes are blueprints. Okay, instances are objects created from a class, and they can have their unique attributes. You can say properties. Can you call the properties? Can you call properties? Can you call attributes as properties in Python? Alright, yeah, but subtle distinction. An attribute is simply a value stored in an object. So, okay, property. So, if I have a question of what is attribute, how should I answer actually? An attribute in Python is a value associated with an object. It can be a variable or a property, okay. Attribute is a value associated with an object. That works. Okay, so print a plus b. That is a concatenation, basic concatenation. Vowels in a string, no control flow allowed. Okay, so concatenation. Okay, I'm starting to like this spider. So the basic idea is you store the vowels and you map it. Oh, no control flow allowed. How do you count the number of vowels in a string in Python with no control flow allowed? Python ignore loops or if solution that is not only possible. Some filter. Sum of char in vowels for charness. No. List filter. Alright. Find all. Find all. We use map here. Can you explain that? Map applies a function to every item of an iterable, returns a map object or an iterator function and iterable. Okay, lambda c, it takes a function and it takes an iterable. Lambda c, it is a function, it returns c novels. Yes, okay, it takes a, so lambda basically, a map takes a function and an iterable. So use the lambda easiest. The iterable is our string iterable and iterator. So string, no, don't use that. str1 is equals to, let's do Shankar. We got a and we got another a. Okay. So do you still need to use the count? Okay, map returns sum of result, some constraint. So since we are using in, sum of map dot can't we as dot count. No, you wrote print sum of map as dot vowels, sorry, as dot count comma vowel. So map close, sum close, and print close. Map, okay, as dot count is a function. Is dot count a function of string or just what does it mean? Okay, count everything. So as dot count is a method itself. A callable object calls the method immediately. Built-in method. So dot takes a parameter and Methods and functions. Method and function are different, okay? Method is called with a not operator. It belongs to an object and it is self parameter. Rest method. And is a built-in function, not a method. Okay. Method, it is a function. Function. Method is called with a dot operator. So here as dot count is a method without parameters. How come? Without parenthesis is just a reference to the method, not a call. No parameters are provided. Okay. Oh shit. Map needs a function and an iterable. Iterable or iterator. So s dot count becomes the method itself. Count or sum of s dot count map of s dot count comma b. Here s dot count is the method, b is the iterator. So this returns the, what does map return? Some. Okay, map a plus function to each item in an iterable returns a map object which is an iterator. Okay. 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 A map object will be produced. We gotta try this out. V is equals to A E I O U. A E I O U. So let's store that result is equals to map. Map needs a string one dot count v print result print sum of result map object okay, or we can do this, shall we? List of result. That works? Yes, that works. Why is there two? Okay. I'm dissecting it. Where did it go wrong? Alright, this part is fine. So iterators can only be used once. Map returns an iterator which is exhausted after the first use. consumes the iterator completely. Now the iterator is empty. Map returns an iterator. Okay. Okay. Nice. Call nope. Refer to as not count. The method itself. Since you are not calling it. As method and the iterable is the way. Sorry, string one. So s is equals to, let's do Shankar. So v is equals to AIOU, AIOU. So, right. Count is equals to, you can do list of map of s dot count. And we print sum of count. Works. Let's do Shankar get to worked map for ovals. Given key exists in a dictionary or not. You create a dictionary. In, you will use the in operator. Yes, sir. If it exists or not, you will check the in operator. It's that simple. I guess the time's almost over. No. Is the time over? Okay, somebody's calling. Right. Alright, so let's complete this. Yeah, so we completed an hour. Yeah, let's do the dictionary and get this over with. So it takes key value pairs, right? Let's do name. Let's do it as name is the key, Shankar is the value, and age is the key, 18 is the value. Yep, that dictionary seems simple. So if all right, name in dict1 print yes, else print no. We're just checking the logic. Yes, okay, and you can also store it in a variable. Key is equals to, let's do like Collins. Let's do like key here. So that should print no. All right, if name, I will demonstrate both the methods. Print yep, else print nope, no, and yep, okay. Both ways. So what's the name of this one? Key indict. Nice, we have completed a lot of programs today, and we're going to take a break. So have a good day, everybody, and see you. Do we have any charts? No, we don't have any charts. All right, bye.